Welcome to Empowering Accessibility using the Microbit and 3D design for switch interfaces. This is our agenda for today. We're going to talk a little bit about what switch access is in case you are not familiar, have not heard of it, or are interested in it. How does it support independence for users? Bill is going to kick us off and tell us about the microbit and make code and how to make custom computer interfaces. Rob will then take us into 3D design, 3D printing, and show off their amazing tap. And maybe hopefully we'll spend a little bit of time talking about how this can apply to maker education, since we're all sort of interested in tech for good. So my name is Loretto. I'm an occupational therapist, and I also have a master's in educational technology. I started a nonprofit called Zero Day Camp with some fellow parents with a focus on computer science, and I love all things assistive tech and the like. Bill?
Thanks, Loretto. Hi, my name is Bill Siever. So I'm a teaching professor at Washington University in St. Louis, so you can read that. So a lot of what I do is I teach introductory computer science classes and things like Internet of Things, where you're trying to connect computers to the outside world in some way. I've also spent a lot of time working with this platform called the Microbit, this little thing. And I try and support K through 12 educators. And one of the products of that I'll show you today is something that's designed to make this thing easily able to control computers in various ways, acting like a keyboard or a mouse. So with that, I'll turn it over to Rob.
Hi guys, I'm Rob Mafrici. I work as the lead designer at PrintLab. We work on doing 3D printing tutorials for schools and universities and makerspaces. My background is in product design. I got a master's in industrial design at Brunel, and I spent 5 years working in the toy industry, working for companies like Lego and Hasbro, prototyping and using a lot of 3D printing. And I've been really enjoying bringing that knowledge into the assistive technology space.
Yay. I'm so excited for this this trifecta of people. All right, so let's talk a little bit about switch access and what it is and how it can develop independence. So for people that aren't familiar, switches are devices that people with disabilities use in order to activate toys, control the environment around them, computers, or alternative communication devices. This little animation is like a illustration of what it's like to add a switch to an adapted toy. So if a child can't play with a physical toy the way it's commercially designed, you can kind of hack it and add a switch and then make it accessible. So it could be either for motor reasons or strength, or there's a variety of reasons why a user might want to use a switch. There's a whole bunch of examples of switches. There are commercial options and also a growing variety of open source 3D printed designed options that have a few components in them. The ones that are simple and mechanical have like a tactile switch in there and a mono jack cable. And then there are some that have sensors in them that can detect light or motion, and then those will activate and turn into like a switch press. So there's a wide variety, just like we all have all different body types and shapes and abilities. But the sad thing is that even though there's a little mono jack that looks like you should be able to plug it into your computer and then use your computer, alas, you cannot. The computer doesn't really know what to do with the switch once you plug it in. So there are these devices called switch interfaces that translate this button press or input. It tells the computer what to do with that particular press. And so there's they're either like hardwired ones that can be directly connected through a USB port, or you can also have a Bluetooth connections to them. And then you can kind of also do mouse emulation, media controls, and all kinds of great stuff through the switch interface to get some independence. And the thing is that the switches and the switch interfaces are actually pretty expensive. And if you're in the medical field, you have to write a lot of justification letters, and it takes a long time to get them. There's a lot of bureaucracy. So this whole thing is really exciting, and being able to put these concepts into more people's hands and to play around with it and to kind of see really what's possible. Another thing to consider is mounting and placement. So not all users will use their hands to activate their switch. They might end up using their foot, maybe their knee, maybe their elbow, maybe their head. And so there's a really nice design challenge of trying to figure out the best access method and kind of where the user is going to be. And then there's this thing called mounting. And so when you find the right spot, how do you get your device to stay in that spot so that you can consistently reach and activate your switch? All right. And once you have all these things put together, you have your switch, you have your switch interface, you have your mounting, you're in the right place. You can really start thinking about really developing independence and take it from there, because the world is now digital and there's so much that we can now do. So you can do things like communicate either through communication apps that are grid-based and will do text to speech. For users who aren't able to use their voice to speak, to sending emails, getting on social media, activating mobility. Adaptive gaming is like really, really taking off right now. So to do some things like that, activating the software on your computer, your Excel and all kinds of software, and also just really, being able to go on, Fresh Direct and get your groceries, or Amazon, and develop some independence once you're able to have a good setup. I do want to just have a caveat to say that like this particular setup that we're talking about is to encourage independence, but it should in no way be used for life critical systems like, calling 911 or, driving your motorized wheelchair, or so this system is really meant more for quality of life and getting more independence out of there. So that's my little disclaimer. Now I'm gonna pass it over to Bill, who's gonna talk about the Microbit and how user-friendly it is. So I'm gonna stop sharing.
Thanks, Loretto. So yeah, I am going to take over sharing now. So let's, apologies. There we go. Okay, so hopefully everyone can see my screen. Picking up where we just left off, I'm going to go ahead and go to this microbit overview and talk a little bit about what the microbit is and why it exists and why it's particularly good for this sort of application. So this is the Microbit Foundation, the Microbit Educational Foundation's overview of the microbit. It's a tiny little microcontroller. It was really created to encourage kids to pursue new things in technology, computer programming and building and making things. So it really does it's kind of a perfect little device to encourage children to create solutions to problems, kind of like the problems we're talking about with accessibility. It supports a whole bunch of different sensors. It's got built-in light sensors. It's got a built-in temperature sensor. It can sense sound. Now, its ability to sense sound is pretty limited. It can sense motion. So it's got an accelerometer, which can sense tilt and motion, which could also be really useful in the applications we're talking about today. It can detect magnetism. And of course, it has some buttons built in. So this kind of graphic of the microbit has the two little buttons shown with these little square boxes, little clicky buttons. and that's the switch that our switch devices are actually going to utilize. It also has some LEDs built in, these little lights, which can be used to kind of show its behavior. We'll include an example of those in our little example demo program too. And then one of the really important ones for us is it's got a radio built in, and that radio allows it to talk to devices that have Bluetooth capability, like almost any modern computer or cell phone or tablet. So it's really kind of the combination of having some buttons and being able to speak Bluetooth that enables what we're going to be doing today. Okay, so with that, I'll take a quick look at the actual programming environment for the microbit, which is known as MakeCode. In the slides for today, there's a link to the full program that we're going to be looking at. So when you click on that link, it takes you to makecode.microbit.org, which is the programming environment to put code on the microbit. And this includes a full example of the program we're looking at today. I'm going to go ahead and hit the edit button to open that up in the MakeCode editor. And I'll take a few minutes and kind of talk about the pieces of the editor and what this program actually does. Again, you're welcome to ask questions in the chat at any time. So the editor is kind of broken up into a couple of different pieces. Over here on the left is a simulated microbit. For kids
Bill,
doing...
I think we may have lost your screen share, or at least
Oh,
I did.
I'm sorry, what are you seeing on your screen?
I see you.
Oh, well, that's a bummer. Hang on just a minute. Let me try that again. We sure did.
Maybe I'm just looking at the wrong. Oh, you
Yeah,
see
I can see you. I can see the screen though, Bill.
Okay.
I can see your MakeCode screen.
Okay, fantastic.
Sorry.
Yeah, Zoom has added a separate tab where you can look at just the people, or you can look at their shared screen. So,
Okay, sorry.
okay. Yeah, anyone else having trouble seeing me? If so, I'll pause for just a minute while we all orient. Okay. See both? Fantastic. Okay. Okay, so in the MakeCode environment, on the left here is a simulated microbit. It's great for kids developing code. They can test things out in simulation. We won't particularly use that today. There's this little slider where you can hide it too. In the middle is a section called the toolboxes. The toolboxes are basically the parts that you use to construct your computer program. They are color-coded, and they have little icons here to indicate their purpose. The ones that are of interest to us today are primarily the ones down here with a keyboard, mouse, media, and in fact, we'll only be using keyboard today. But I mentioned earlier that this device can actually emulate other things like a mouse. You can actually make a wireless mouse that uses the accelerometer on it to use tilt of the microbit itself to control the mouse on a screen. So that would open up the world to a whole other class of accessibility devices. So when you click on the individual toolboxes, they show the little parts that you can use to construct a program. And you'll notice that they have little kind of cutouts, notches, teeth. Basically, these act a lot like Lego blocks. You click things together to construct your program. So we've already got the entirety of the program that we need today over on the right. This area is kind of our work area. So again, you can snap things in and out like Lego blocks, and they make kind of weird clicky noises when they get snapped together. So I'm going to briefly move around and talk about each of these major components of the program, just so you'll have some idea what it does when it's actually running. So I'm going to go through this kind of quick, but again, there will be a recording and slides after the fact. And for the most part, it's possible to just take what you see here and tweak it and modify it to suit your purposes. So starting in the top left, the on start block is what the microbit does when it first starts up. And we took one of the blocks from this keyboard tool set, the Bluetooth keyboard service, and we put in there. So when our microbit starts up, it's going to act like a keyboard. And we also put this show icon with a little heart in here. So when our microbit starts up, if we see that heart on the screen, we'll know that it's running this code. So that just helps us make sure that, that it's behaving correctly. This next little block down here, on Bluetooth connected, came from the Bluetooth palette of blocks on Bluetooth connected. And whatever we put inside of here will activate if it connects to another Bluetooth device. So again, we're using our screen here, and it'll show a smiley face when we connect to something. So in a bit, we'll do a demo of it connecting to an iPad, and we'll see that smiley face appear. And then similarly, in the Bluetooth palette, there's on a Bluetooth disconnected block and we put a little X in there. So the screen will show a little X if the Bluetooth device ever disconnects. So our little microbit will show a heart when we turn it on. Hopefully, that'll confirm that our code is on it. When we connect it to the iPad, it'll show a little smiley face. And if the iPad ever disconnects from it, it'll show a little X. So these kind of show us the status to make sure that it might be behaving correctly. Oh, I see someone is drawing on my screen. Hi, Anne. Do you have a question? Maybe I will disable drawing on the screen. Bear with me just a moment, everyone, while I look at those controls. Go. I'm going to momentarily stop the screen. Okay, so we've kind of talked through the three different components of our program over here. Then the two really important ones here are we picked some blocks from these palettes on button A. So on button A is what happens when the little A button on the microbit is clicked. So when button A is pressed, we're going to show a little picture of an arrow going to the east, going to the right. And then we picked this thing from the keyboard palette. It's going to send keys. It's going to send the tab key. So our microbit's going to act like a keyboard. And when we press button A, it's going to send the tab key. So that's what the iPad's going to be listening for and reacting to. Then it'll pause for a brief amount of time and clear the screen. So the little east-going arrow that's drawn on the screen will go away. Button B is very similar to this. We'll show an icon that represents a check mark. Button A was, oh, okay. Maybe I didn't completely disable the drawing on the screen. Well, we are going to stop sharing once again. Get the screen cleared. Okay, so button B, check mark, will send the enter key, kind of a confirmation thing. So one is for advancing to the next option on our iPad, and the other one is for confirming things. Okay, so that's the overview of our program. Again, if you have any questions, just drop them in the chat. This editor is free, online, available. It's provided by and supported by Microsoft. And this is really about the only editor that you can do this stuff in. And
we do have a question about if you have to use the editor provided with Microsoft, or can you do a different IDE or VS Code?
You can't really do VS Code. In fact, this particular editor is the only one that supports the particular blocks that we're using. So hang on just a minute here. And I'll start sharing the screen again. Okay, any other questions?
I think there was one about, the difference between Arduino AVR and the Microbit.
Oh, sure. So yeah, the Microbit actually runs a much more sophisticated processor than the Arduino does, the Arduino AVR anyway. And the reason it's somewhat useful here, it's a pretty good price point. It's around $20, and the Bluetooth support is really what adds in the ability for it to do the switch access. There are other Arduino-like things that can support Bluetooth. So it's not your only option. It just happens to be convenient because the block-based editor here makes it really easy for almost anyone to create these programs and edit them. So, yeah.
Yes, like noobs like me. The idea is to really encourage more people to be able to do this.
Yeah, so I am... Yeah, the BLE stuff is pretty cool. Again, I'm going to stop sharing here very briefly while we clear the screen, and I'm slowly evicting people who are drawing on my screen. So, yeah. Oh, yeah, there was a question about adding some sound and some feedback. The Microbit does include a speaker, so you can actually do some sound in response to someone clicking on a key. So, yeah, any other questions? Okay, so I'm going to move on to how do you actually get this program that I've written on the computer onto the microbit. So I've plugged in the microbit to my computer with a USB cable. I'm in the Chrome browser. The things that we're doing today work really well in the Chrome browser or in Microsoft's Edge. They don't work in Apple Safari. Apple Safari doesn't have any ability to communicate with devices over a USB cable. So I've plugged in my microbit. When I plug it in, it gets power. The lights on the back of it turn on. In my little editor environment here, I'm going to go down to where it says download. I'm going to click this ... thing, and it says, oh, connect device. And it walks me through a couple of screens here that tell me how to connect it to my computer. By the way, a question in the chat is, does it come with USB? It comes with a tiny, typically when you buy the microbit, it comes with a small USB cable. You can usually plug it into most computers. And there is another reason to start. Yeah, you may need an adapter to get it to work with USB-C. And I did not catch who was drawing on the screen that time. If anyone did, please drop it in the chat and let me know. So it describes how I need to interface to the microbit. I plugged it in. I'm going to go ahead and hit the next button here. It's telling me that in just a second, a message is going to pop up that is going to describe in my web browser how to connect the microbit. I'm going to hit the pair button here, and this thing pops up, and I'm going to pick that I want the microbit. I'm going to hit the connect button. And it takes a second, connects to the microbit, and it says now it's connected. At this point, my web browser can talk to the microbit and some... okay, so back to screen share. So I hit the download button. It sends this code over to my microbit. As it's doing that, it says downloading on the back. And sorry, it says downloading. The little light on the back of the microbit blinks as the code is being transferred over. And now that the code is transferred over, my program is actually running, and it actually shows the little heart. So I can see that my code was successfully transferred over, and my microbit is now acting like a Bluetooth keyboard. So now I'm going to switch over and take a very quick look, and Rob is going to walk through this stuff with you as well. I'm going to take a very quick look at what my iPad looks like, and I am going to go ahead and open up the settings on my iPad. And I'm going to search for switch. It says, oh, switch controls. I'm going to go ahead and pick that. And then I'm going to pick this area of my screen that says switches, and it's showing 0. Don't have any switches configured right now. And when I take it here, it gives me the option to search for Bluetooth devices. I'm going to go ahead and click on that. And it's going to search for devices around me. There are a whole bunch of Bluetooth things around me, but there's only one thing acting like a Bluetooth keyboard. And it's shown right here, U-bit, U kind of standing for micro. And then it's got a code. Each microbit has kind of a unique 5-letter name. So I'm going to go ahead and pick that. And my iPad asks to pair. I'm going to go ahead and pair. It'll take a second. My microbit has just changed to the smiley face. If you remember, once our microbit was connected to a Bluetooth device, it changed to the smiley face, and my iPad now says that it's connected. So at this point, I can hit this, go back to the previous screen, and oops, not work correctly. Bluetooth devices. Yeah. Sorry, I think I'm reconnecting to it now. Oh, add new switch. So by the way, back to the previous screen, add new switch, pick an external switch. And now if I click on my microbit, it will send over, when I press the A button, it sends over this thing that I want to move on to the next screen. So I'm going to go ahead and type in next, and that will be my next button. And it will select the next item. So I'm going to go ahead and pick move to next item. I'm going to repeat this process and add one more new switch. And again, it's going to be an external switch. And I'm going to use, this time I'm going to click B on the microbit, the check mark. And I want this one to select an item on the screen. So I type in select and hit save, and I actually pick the select item thing. So I've added two of the keys, the A button and the B button on the microbit. Well, one of them will move me on to the next thing, and the other one will select the thing that it's currently on. If I go backwards one step to the switch control screen, I turn on switch control, and now that's enabled, and my microbit will be able to allow us to interact. And in fact, there's a little highlighted item up at the very top that of my iPad screen. Okay, so I'm going to take a quick look at the chat. Are there any? Yes, there are questions in the chat. Are there physical buttons on the microbit? Yes, there are two physical buttons. And yes, there's the accelerometer, kind of gyroscope sort of thing on the microbit that can be used to act as a mouse. So with this, I am going to stop my screen share and I will turn things over to Rob.
Okay, cheers, Bill. I will just share my screen now. Okay, so thanks, Bill. I'm going to just introduce myself. So I'm Rob, lead designer here at PrintLab, and along with my colleague Jason, we've created a 3D printed add-on for the BBC Microbit, which turns it into an assistive button. We're calling it a tap, and I'll be using it as a case study to walk through the potential of 3D design and 3D printing when using assistive devices. So what is the tap? The tap is two things basically. Partly it's the code that Bill just went through, and we used Bill's BLE plugin to make the code for the tap. And you basically drop it onto the microbit like Bill showed, and it essentially turns your microbit into a wireless keyboard. The second part is our 3D printed case that we've created to house the microbit. And this case allows for a range of different button options to be added specific to your end user's needs. So our key goal when we were creating the tap was to make it really easy to print, really easy to assemble, and really easy to customize. So as you can see, we've already created some example buttons for the community to play around with. But our main goal with this project was to give the community all the tools that they needed to create their own custom buttons for the device, specific to their end users. So here's an overview of the components. As you can see, there's no screws or fasteners or complex mechanisms to deal with. You simply stack the components together and then slide the case over to hold them in place. We kept the design simple because we wanted this to be assembled by as many people as possible, as easily as possible. So we kept the design simple to just make it a lot more approachable for people. So all the files for TAP are open source, which I'll go into a little bit later in more detail. But first, I just wanted to go through the process of how you go from our open source files to like an actual final working product. So once you've downloaded the files, we've got an accompanying documentation that you can read through. But the first thing you'll want to do is start by 3D printing all of the parts. We put a lot of time into making the design really easy to print. So this means that there's no support material and no complex print settings that are needed. It's just kind of print and go. The print time is only around 3 hours for all the parts, and that can be even quicker if you're using one of these modern Bamboo Lab printers. And it's also super cheap. I think all the parts for a tap are under $1, which when you think of the current assistive buttons on the market, it kind of shows you the amazing potential that's kind of unlocked once you start using 3D printing to create your own products. So here are all the 3D printed components. For ours, we chose orange buttons and a grey case, but kind of that's one of the beauties of 3D printing your own stuff. You can pick and choose whatever colours you like. And some of you who might have already used the Microbit before might be wondering why we don't have a button for the reset button on the back. Well, to keep the part count down, we decided to build that button into the case as a flexure button. And this again makes assembly easier and is just another example of how you can use a bit of clever design to make your user's assembly experience a little bit easier. And that's kind of been at the forefront of the design of the tap all the way through. We just wanted it to be as easy to put together as possible. So yeah, once you've got your 3D printed parts, the next step is to upload the code, like Bill showed. And it's with the code that we've created, we actually include the hex file in our documentation. So you don't have to program it yourself. You literally just drag and drop it onto the microbit like you would just copy any file onto a USB drive. The default code enables Bluetooth connection like Bill showed. And it makes the A and B buttons send the tap and enter keyboard outputs when pressed. With some simple edits, though, to the code, you can customize it to do all kinds of things. Like Bill said, there's so many different sensors built into the microbit that, like, the world is your oyster, really, if you want to go deep into modifying these things for your end user. So when the code's uploaded onto the device and you've got your 3D printed parts, all you have to do is place the microbit into the cradle, put the buttons on top. They just rest on top of the existing buttons on the microbit. And then you slide the lid over to keep the microbit and buttons in place. And then all you have to do then is plug in a battery pack and you're ready to get started. You can use the battery pack that's included with the microbit, but it can also be run off a USB cable from your device. So I'm going to just kind of skip over this because this is what Bill showed, pairing the microbit. But I think the thing to like really hone in is that, like, you can go in as deep as you want into this code and you can modify it to do all kinds of things. We're trying to create a platform that you can then add on to, and all the documentation that we're building around this will hopefully make it easier to do that in the future. So again, this is kind of going over how this works with the assistive control. And here in this example, we're using an iPad, but this can be used on all kinds of devices. And it still kind of blows my mind that you can activate pretty much all the functions on a really complicated device like an iPad with literally just 2 button clicks. And the ability to do that now is just absolutely amazing, and with something that's as cheap as the microbit. So here's an image showing the tap being used with a different set of buttons. This one has some grooves in it to guide and direct your fingers. And this is a really simple design, but there really is no limit to what you can do in terms of customizing the device with 3D printing. And really, I think the best way to show this is to just show you in CAD how we'd go about doing this. So the tool that we use to create the tap device is Fusion 360, and this is a free tool to use for education purposes. And yeah, like I said, we use this to create the whole of tap. So before I jump into CAD and show you like a little quick demo of modifying the CAD model, I should probably state, like, there is definitely a learning curve when it comes to learning a CAD program. And we've got some resources to help beginners out with this, which I'll talk a little bit about later. But I'll quickly just jump into my Fusion file, and let's see if I can share the screen without anything breaking. Okay, is that showing up? Great. Okay, so this is the Fusion file that we have added in with the documentation when you download the tap. So you can open this up once you've downloaded Fusion 360, and this is what you'll get. And this is essentially exactly what we were showing earlier in the files. It's 2 buttons and the case. And I'm going to just kind of gloss over a lot of the functions on Fusion. But what I want to show here is that with a few simple tools in Fusion, you can do some amazing things. And all you have to really learn is the interface and 2 or 3 tools, and you can do a lot with opening up other people's files. So here we have the main model, and then on the side here we have all the different components, and we've labeled everything so you can turn on and off the components. So we start off with the microbit, and then we've got the cradle that the microbit sits into. And again, this is literally just sits in, and its tolerance to fit really nicely. And then we've got the A and B buttons that rest on top of it, and these interact with the buttons on the Microbit controller. And then finally, we've got the sliding case that slides over and holds everything in place. So what I'm going to show you, here's one I made earlier, basically. So this is what we're going to create. We're just going to show how you can modify this existing button and create a simple extruded button with some lettering on it. So what I'm going to do is just delete that away, and we'll go through the motions. So starting off with pretty much anything in Fusion, you always start with a 2D sketch, and then you extrude it out into a 3D object. So we'll start by selecting the button, right click it, and then create a sketch on that. So now we've created a 2D plane in which we can draw a sketch onto. I like to start by pressing P for project tool, and this will project the square that we're working on. Press O for the offset tool, and now we've offset that initial square, and we can offset that by an arbitrary number, let's say -2. So what we've essentially created now is just a 2D sketch of a square. When we click that, we can press E for the extrude tool, and now we extrude out. And that is literally the basis of pretty much any 3D model. You just draw a 2D sketch, extrude something out, and then build on top of that. So let's extrude that out by 5. We've got some sharp edges here. So here's another tool that's really simple, the chamfer tool. You can click on that, click on the edges you want to chamfer, and again, put in a random number. So let's say 2, and we've chamfered that edge. Finally, we're going to write the letter on top. So create a new sketch on this top button. We'll press L for a line. Select that line, and we're going to go onto the text tool and draw on top of that line. And this works like any text editor. You can type whatever you want, but it's the A button, so let's put an A. Now you can change font, you can change sizes. It's all really simple, and it's quite intuitive to use. So now, just like we did with the other sketch, we can select it, and we can extrude it out or cut it in. And I mean, this is a really simple example, but you can just imagine for visually impaired people having things that will help with identifying each button through touch. This kind of stuff is invaluable. So this is just a really simple example of some of the things that you can do. And one final thing I'd like to show, which is how I kind of learned CAD when I was getting into all of this, because I'm self-taught myself. What I used to do is open up models like this, and I would like reverse engineer how they were built. And this is a really cool feature on Fusion 360. There's a timeline that you can pull back, and then it will kind of take you back in time, so you can see how each part of the model was made. So as you move forward in time, you can see how each extrude builds upon itself to make the final model. And you can jump in at any point of any one of these features, and you can edit them. So in terms of being able to like take a model that you like online, and you want it to be, say, a different size, or you want a different small tweak doing, you can just jump in and do that. So that's my like super quick crash course on Fusion 360, and I'll just jump back to where we were in the slide.
There was a question about if the text editors have other alphabets or support them.
I think they do. I think the preset is in English, but I think there are ways of adding in different languages and different fonts and specific fonts for things like Braille and things like that. Right, so finally, that kind of leads me on to the thing that I'm kind of most excited for with the TAP project, and that's the open source documentation. So the base file that I just showed is included in this documentation.
I
But
think
I'm not,
I'm not the Zoom expert, but I think we see your notes.
oh,
the screen with your- yeah,
oh dear. I'll jump back in.
I'm learning Zoom myself again post pandemic. I think right.
Let me just see if I can change it.
Yeah, now we see the browser.
Slideshow. Can you see the notes now?
Yes.
I guess. A peek behind the curtain. So, yeah, so back to the documentation. I think really for this kind of thing, sharing files online is great, but um, it's so much more powerful when you can share like the essential information that can help other people edit and build and adapt and improve these files. So we've really gone to town with the tap, trying to give as much information as possible so that it's easy for everyone who wants to add to it and modify it. Um, they can do so. So in the maker guide, it includes everything from the design rationale for the project to a step-by-step print assembly and usage instructions. We've even added a section at the end with ideas on how to evolve the design further. And I think this, more than anything, is something that I would like to see done more in the future with open source projects. So much thought and so much time goes into the project and thinking that never gets shared with the wider community. And I think that for me is probably the most important thing that comes out of these designs rather than the design themselves. So yeah, for me, the real power of open source and 3D printing is the ability to leverage other people's time and other people's knowledge and expertise. So being able to share that and make it easier for people to add to that is really, really important. So I implore you, please download the files. Please have a look at what we've done, and I'm really excited to see how people add to this project. And we'd love to get some feedback as well on what you think is missing and what you think could be added to our documentation. So yeah, I hope you've enjoyed learning about the design process of TAP. If you're interested more in the 3D design side of things, we have an online course that guides you through the whole process of designing the TAP from scratch, showing how we did that in Fusion 360. And the idea of the course isn't that you just learn the 3D design side of things. It also will let you identify an end user for your own project and design a custom version of the tap that specifically fits their needs. This might mean designing a unique button or a mounting system, and it can even mean completely changing the code, but we guide you through that process step by step in the course. The course is available as part of our PrintLab online platform, which does have an annual fee, but we welcome you all to sign up for the free trial and have a go at some of these tutorials and just see if it is useful for you guys. And specifically for the tap, I'd love to see people using it. But in addition to the Fusion 360 tutorials, which I just showed there, we've also got stuff for Tinkercad, which is a slightly more beginner-friendly CAD software. And it will show you how to design a slightly simplified version of TAP using Tinkercad. And on a personal note, I never used Tinkercad before starting this program. I'm really like blown away with what you can actually do with such a simple program. So yeah, that's another great starting point for learning how to kind of modify and create free programs. So yeah, you can start your free trial at PrintLab, and we'll have a link on the slides if anyone wants to have a look into that. But yeah, I'll hand it back over to Loretto now to wrap up, and thanks for listening.
Yeah. Do you want to just do the? Oh, okay, I'll share.
Like,
That. Okay, this. I think we only have one slide left. And that is, I think here, right? Maker Ed. So as you can kind of get an idea, PrintLab is amazing. And everything that I learned, I learned from them. It's really, really wonderful and like very user friendly. And but this is kind of the idea of maybe starting to think about, if you are doing 3D design if you're in the educator world or some kind of design courses, to think about designing for good and thinking about who needs what around you, and being able to like really empathize and think about the people that need your help, and coming up with projects that are really meaningful and helpful. And so that also includes all the computer science educators out there, and being able to come up with some like really great helpful projects and helping this community of makers grow. So these are some resources. And also, so our website has a few projects. We also and instructions for similar devices that also work with like other boards like Circuit Playground and Trinky. But the idea is to use a lot of block-based coding, so to lower the barrier and the frustration level around text-based coding and why doesn't it work, and so to really bring people in and be able to come up with these custom very personal solutions. Stop sharing, see if there are questions or thoughts or
Yeah, if there are any questions, drop them in the chat. I am going to go ahead and turn on allow people to chime in and unmute themselves. So yeah. Yeah, so some
yeah, I will put
requests
those in the
to
chat.
drop things in the chat. Yeah. By the way, I'm going to go ahead and drop my email address in the chat. You're welcome to contact me directly with related questions.
The thing that's really nice about this project too is that, yeah, it has all those built-in sensors, and you can also connect things with the alligator clips to the pins, the grounding pins at the bottom. So if you can't solder, it's okay. You could still connect stuff to it with conductive materials, sort of like the Makey projects. And then it also supports great things like mouse emulation and media controls. So being able to like play and pause your YouTube videos and your sounds with a pretty low cost system is great. Yes, like a catapult. Chris made an awesome catapult out of his microbit. He connected a little switch operated catapult that it's connected to a servo. So a little motor that turns and it releases the latch and lets the catapult spring. It's very impressive, Chris, if you have a picture of it. Oh, so the other projects, so they're on the Zero Day Camp website. I think if you go in the blog, I will.
At this point, I am also going to stop the recording.